In section 1-2, we're going to look at segments, rays, parallel lines, and also parallel planes. So we actually have 3 different learning goals that we're covering in this lesson. The first is that students will understand how to use correct naming conventions and labeling for 2-dimensional, 3-dimensional figures. So this is using all the right notation and symbols to indicate what you're talking about in your diagram and in your work. The second is that students will identify and describe relationships of figures in 2-dimensional and 3-dimensional space. So how do you explain how 2 figures are coming together and how they meet, what the relationship is? And then the third is that students will understand the relationship between segments, rays, and lines. All right, so let's start a little bit with our notation here. A segment is a part of a line, a whole line that extends on forever, and that segment consists of 2 endpoints and all of the points in between them. So you can see we've got a little segment here, the red part, starts at A, travels on, stops at B. So A is an endpoint, B is an endpoint, and this is the whole segment. The way we write segment AB is to use the capital letters, because those are points, and then a line on top. Notice how the line on top doesn't have arrows at the end? That's how I know it's a segment. In this particular case, it would also be acceptable to call this segment BA. The order of those endpoints doesn't matter when you're naming it. A ray, on the other hand, is a part of a line that consists of 1 endpoint and then all the points on one side of the endpoint. So all the points that keep going. A ray keeps going forever and ever and ever. It only has 1 endpoint. Here this red part, of course, would be ray AB. That's how we would say it out loud. So when we're doing notation, this is actually really important. The first point tells me where the ray starts. It starts at point A. The second point tells me that it goes through point B. And this is actually quite important when we're looking at direction. Let me give you another example. If I had a ray that went like this, let's call this S and T, I would have to call this ray TS because the ray begins at T and then it goes through S. And my arrow would still point to the right because it always points to the right. Even though my ray is pointing to the left, when I'm drawing the symbol, the arrow always points to the right. So that might be something that you put in for like a little note here. Arrow points to the right. Always. Okay? All right, a little bit more notation and vocabulary. Opposite rays. Opposite rays are 2 collinear rays. So we should talk about what it means to be collinear. Oh, that means on the same line again. So they're 2 rays that are on the same exact line with the same endpoint. So it's kind of like exactly what it sounds. Opposite rays go in opposite directions. So we have one that's going to the right, we've got one that's going to the left, and they're sitting on the same line. So together, they will always form an entire line. But there's only one endpoint there, and the endpoint is the same. Okay, so now I want you to do a little practice here. In a minute, I want you to pause your video, and I want you to try to draw a line that have points C, D, and E all on that same line. So pause the video, draw that line, and put those points on them. Okay, once you've done that, what I'd like you to do, hopefully your picture looks like this. Now what I want you to do is think about this and figure out what could be the same ray in this case. There's a couple of different correct answers, but what are 2 different names for the same ray? Okay, so if you're thinking about which rays could possibly be the same, they would have to have the same endpoint and they'd have to go in the same direction. So in this case, ray CD starts at C and goes through D, so it goes in this direction, would be the same as ray CE. Starts at C and goes through E. that's still the same ray going in the same direction, right? Okay, now CD and CE, let's kind of recap this, are the same ray, but DC and DE would be opposite rays. So pay attention to these two down here. DC kind of goes up, but DE starts at D and goes in the opposite direction, so those would be considered opposite rays. All right, let's talk about how lines have different relationships in the plane. I know you guys know what parallel lines are. They look like this, right? The two lines that never intersect. But not all lines that don't intersect are parallel. So lines that don't intersect may or may not be parallel because they may or may not be coplanar. Remember that word coplanar means on the same plane. So let's take a look at a couple of examples here. Parallel lines don't intersect and they are coplanar. Those are the two properties of parallel lines. Let me lift this up a little bit. So think about this. There's the same flat surface that would go through those two lines that never intersect. So here's a little diagram of parallel lines. We got two lines. They look like they never intersect. I've labeled them M and K. So we have line M and line K. And what we do is we always use arrows on the lines to show that they're parallel. So see these two arrows right here? Those guys are the lines, the little arrows I use that I know from the diagram that those lines are exactly parallel. And this is the notation that we use for parallel lines. So we'd say M is parallel to K. It's two lines that look like they're parallel. Okay, so now let's talk about skew lines. Skew lines also do not intersect, but this time they are non-coplanar. In other words, they don't live on the same plane. So I want you to visualize a three-dimensional box for this. And to draw that box, it helps to draw two rectangles. We'll practice this in class. I'll show you my little trick. But draw two rectangles that kind of overlap and then just connect the corners. So I want you to look at this line that is extending kind of in that front corner but horizontally. And then I want you to look at this second line that's extending in the back but vertically. Basically what's happening is these lines are going like this, right? And if they're going like this, they're not meeting, right? They're in space, they're far apart from each other, but they're not going in the same direction, so there's no way that they're coplanar. There's not one plane that goes between the two, or that could contain the two. So these are what we call skew lines. So that was one of our particular success criteria, understanding what skew lines are. Now we know what they are. Okay? So those are parallel lines and skew lines. Both of them never meet. And then we have parallel planes. So parallel planes kind of, when we draw them, appear to be floating on top of each other, but just like parallel lines, they never intersect. Okay, let's fix that. They never, ever, ever intersect. So write down that note here. Parallel planes never intersect. Now when we draw them, what I try to do is draw a parallelogram like you see here in M, and then I leave just a little bit of space between the top of M and the bottom of T, and I draw another parallelogram that's pretty much exactly the same size and exactly the same shape. So here, if we wanted to use some notation, I would say plane M, remember how we named this, plane capital M is parallel, two little parallel lines, to plane P. And there we have it. Alright, so that's the basics of what I want you to know about parallel lines, planes, and how things intersect in rays and segments, and a little bit of notation. So get all that information down, go back and write your questions and your summary, and bring your notes to class the next time, and we'll use that information in our work.